Welcome to example 3 in 5.2. Again, just steadily increasing the complexity of these functions. We see that there's a lot of transformations happening in this. In fact, this is kind of the full meal deal. We're going to have A, B, C, and D all interacting on one function. Then it asks for vertical displacement, amplitude, period, phase shift, domain, and range for this function. And that's really things that we can generate from the A, B, C, and D. And we're going to talk about how to do that. We're going to focus mostly on that. Now, the sketch itself, you can produce via your calculator. Be careful when you do that, though. I do want to talk through these kind of piece by piece. There's y equals sine x. And what they do in this first step is they do both the vertical and the horizontal stretch. We can see that this graph is now going from +3 to -3, and we're getting 2 periods in the space where we had 1 period. We'll get rid of that original because they are going to basically transform the transformed versions. So next up, if we take a look from my second to my third here, we are going to have just a horizontal translation of pi/3 to the right. And I do really like the idea. I'm going to model that on the board here, that if we take a look at this point, that little black arrow is the exact same translation that is happening all the way along. Right, that is constantly going to guide us from our red function to our green function, and hopefully showing 2 rotations of this isn't as tedious as it kind of feels. Okay, but the last piece, and we'll talk about how they have a different form than what we saw originally in the question in our last kind of summary page here. I'll get rid of 3 sine 2x there, because now what I'm going to do, and I suppose I should get rid of this black line as well, is I'm going to take that green graph and I am going to vertically translate it to up. And I'm just going to write that's the +2 right there that's doing that. And when I take a look at that graph, similarly to the last, although we ran out of space a little bit, I suppose, up top, that is my vertical transformation or translation specifically. And we can see that again, that is mapping every single point from my green graph to my purple graph. Now, your scale is again a little bit different than what I have on the board. You can see that it is divided into pi/12. I would highly recommend that when you put that into your calculator, you make your x scale pi/12, and that'll work the best to basically see exactly what's on your page there. But I want to focus much more on how to get vertical displacement, amplitude, period, phase shift, and so on from the actual parameters themselves. The first thing we have to do is we need to clean up the inside of that sine function, because this 2 pi/3 is not actually applied directly onto x. It's applied onto the term 2x. So we're going to factor that out like we have done in previous transformation chapters, and we're going to write that as 2 times x minus pi/3, and then finally +2 on the outside. And again, writing that general form, I think, has a benefit. This is now in our standard transformation form, which is a big advantage because hopefully it's borderline trivial to identify that A is 3, B is 2, C is +pi/3, and D is +2. All right, now some of these are immediately solvable. We can say that the vertical displacement, so I'll just abbreviate that a little bit, my vertical displacement is the D value. So it's +2, and I'm just going to put the D value in a bracket beside there. The amplitude is equal to 3, and again, what that is the absolute value of the A. The period takes a little bit more work, but it's not bad. Period, we talked about earlier, can be defined as, this is in radians, so it's 2 pi divided by the absolute value of B. That's going to be 2 pi divided by 2, or that is going to be pi radians. All right, the period is done. We have phase shift. The one thing you have to remember about phase shift is it's never a bad idea to put a direction in there. So I am going to put a little bit different order. Phase shift is C, and we're going to say that's pi/3. But I would like to put a right there. Now it is implied because the C is positive, it shifts it to the right, but it's not a bad idea to give a little bit of extra information. All right, domain and range. Now domain is nice. The domain of these functions, there is no invalid input for this x, so it just becomes that x is an element of the real. The range is a little bit trickier, and I want to put in a formula here because it's really useful that my range, that's in terms of y, is really always going to be d minus the absolute value of A to d plus the absolute value of A. That is one of those nice kind of universals that when we're talking about sine and cos, you can jump to that right away. So in this particular function, we could say that y exists in between, so d is 2, A is 3, so 2 minus 3 is going to be -1, and 2 plus 3 is going to be +5. And again, that would still be y is an element of the real. And if you take a look up at that graph, you do see that the minimum occurs at -1 and the maximum occurs at +5.